All right, class, today we're going to cover section 5.3, which is all about special types of factoring. Here we have our first special type of factor. This we call a difference of two squares because I've got x squared and 36 is 6 squared. So let's go ahead and factor this the old way by finding the factors of AC that add up to B. Remember, I'm going to need to put a placeholder in the center here. So I've got x squared plus 0x minus 36. So I need to find the factors of AC that add up to B. AC in this case is 1 times negative 36. So I have a negative 36. So now I'm wondering, okay, what are some factors of negative 36 that add up to 0? We already said 36 was a square, so how about negative 6 times 6? Since my leading coefficient is 1, I can use that shortcut to pull this apart into x minus 6 times x plus 6. So we can still factor the old way, but there is a new shortcut we can learn. So if I have the difference of two squares, so a squared minus b squared, that's always going to, what is happening? That's always going to factor into a plus b times a minus b. So the first key point is going to be to identify your a and identify your b. So here we have the example we did on the last page. A is x, b is 6, and I should make these capital because that's what we use to represent them, capital letters. So that's going to mean I have x plus 6 times x minus 6. It's important to note for all of these, you can still factor the old way. This is just a shortcut. So let's work on some more examples. We already did this one. Go team. What if I have a squared minus b squared, and I've got 4a squared minus 64? What's a in this case? What would I square or multiply by itself twice to get 4a squared? Well, 4 is a perfect square, right? 4 is 2 squared, and a squared is just going to be a. So in this case, my a is 2a, but then what's my b? I've got 64. That is going to be 8 squared, so my b is going to be 8. I can rewrite this as 2a plus 8 times 2a minus 8. Let's take a look at another example, but I'm going to change this pen color because I think it's hard to read. Pen, let's go to gray. It's important to note that some examples may require double factoring. So I've got x to the fourth minus 81. So my a, in this case, if I've got x to the fourth, what would I multiply by itself twice to get to x to the fourth? That'd be x squared. And my b in this case is going to be 9, because 9 squared is 81. I can rewrite this as x squared plus 9 times x squared minus 9. Now I have two binomials, but I need to see if I could factor them. So, okay, are there any factors of AC here, which would be 9, that add up to 1? Nope. Factors of 9 are 1 and 9 and 3 and 3. But over here, this looks vaguely familiar, right? This is a difference of two squares. I've got a new a. My a is now x, and my b is now 3, because 3 squared is 9. So I can keep factoring this. I still have my x squared plus 9. This is prime. It can't be factored any further. Times x plus 3 times x minus 3. So always make sure to double check that you are fully factored. Now let's take a look at this example. This is an example of a perfect square trinomial. And it might be kind of hard to tell from looking at it, but there's a nice shortcut we can use with these in the future. So let's go ahead and factor this the old way. If I have, find the factors of AC that add up to B. AC in this case is 9. So I need to find some factors of 9 that add up to 6. Well, 9 is 3 times 3. So I know this is going to break up into x, because my leading coefficient is 1, x plus 3 times x plus 3. Now look, both of these are the same. We call this a perfect square trinomial because I can write its factor as a perfect square, x plus 3 squared. There's a way to notice if you're working with a perfect square trinomial. If you have something of the form a squared plus 2ab plus b squared equals a plus b squared, or a squared minus 2ab plus b squared equals a minus b squared. So I'm going to leave this for you to determine what your, well, I'll go ahead and tell you. Your a in this case is x, and your b in this case would be 3. And then you write it as a perfect square. I would highly recommend old factoring methods for this type of problem because it's kind of hard to check if you have this perfect 2ab middle term. When it comes to most factoring of trinomials, I would always try our old factoring methods first before these little shortcuts. Let's go ahead and identify what our a and b would be. In this case, it's a little more complicated, and we can go ahead and factor it. So I've got 4x squared. That's my leading term. I can already tell you this is going to be a perfect square trinomial. So my a in this case would be 2x, and my b in this case, b squared is 49y squared. So I know I'm going to have a y, and 49 is 7 squared. So I can rewrite this as 2x plus 7y squared. So this would be a good example of when knowing the shortcut would be helpful and handy. On an exam, I'm not going to give you this type of problem. This is the one you will need to memorize. I even put it in a big note. You will need to memorize this. This is factoring the sum or difference of two cubes. So for example, if I have x cubed plus 27, we wouldn't know how to factor without this rule. So when I have the sum of two cubes, I have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So it's important to identify what our a is. In this case, our a value is x. And I've got a cube plus a cube. 27 is 3 cubed. So I've got b equals 3. And then you just substitute into this equation right here. So I have x plus 3 times x squared minus a times b, that's x times 3, so 3x, plus b squared, so 3 squared, that's 9. This is the one you're going to have to memorize and know how to use when you're working with a sum of two cubes or a difference of two cubes. Let's take a look at another one. I've got 27x cubed plus 125. In this case, my a, I go look at my coefficient first. I've got 27, that's going to be 3 cubed. And I've got x cubed, so I'm just going to be left with a x. Next I have 125. I'm going to tell you right away 125 is 5 cubed. And I'm looking at the sum of two cubes, so I use this formula right here. I know that this is going to be equal to a plus b times a squared, so 3x squared, and I have to remember to square the whole thing. So that's going to be 9x squared minus a times b, so 3x times 5, that gives me 15x plus, I don't know why I put a parenthesis there, ignore that guys, plus b squared, which is 5 squared, so 25. Then I am fully factored. Remember, even when you're using these shortcuts, you need to factor out the greatest common factor first, right? If we didn't do that, this wouldn't look like a perfect cube. The greatest common the perfect difference of two cubes. The greatest common factor of 3x cubed and negative 24 is going to be 3. So I'm going to pull out 3, which leaves me with x cubed minus 8. We can now go ahead and substitute in to our equation. I know my a in this case is going to be x, and my b in this case is going to be 2. So that would leave me with 3x, we're using this equation now because it's a difference of 2 cubes, x minus 2 times a squared, which is x, plus ab, which is 2x, plus b squared, which is